Rhinos are older than tiger, lion, and every other modern big cat. By the time the first tiger ancestor appeared, the rhino lineage already had been on Earth for over 40 plus million years. What you just saw, that's the reason part of our brain is still stuck in the survival mode. Our survival mode is physically rooted in the brainstem, often called the reptilian or the primitive brain. This part of the brain appeared in our fish-like ancestor over 500 million years ago. It handles the basics, for example, heart rate, breathing pattern, the fight or flight reflex. This is called survival loop because it evolved in a world where eat or be eaten was the only rule. It is incredibly fast and operates entirely below our conscious thought process. That's why your ancient brainstem, the fish part essentially, cannot tell the difference between a predator and a stressful email from a manager. Because that part is designed with only one objective, to keep you alive. That's why there are now specific exercises like vagus nerve stimulation that people use to signal to the ancient fish brain that the danger has passed. But at a very base level, Dinosaurs, Rhino, and we have inherited the same basic brain architecture from a common ancestor about 500 million years ago. For example, T-Rex had a brain based on the same vertebrae plan. Rhinoceros brains follow the mammal version of the same plan. Homo sapiens expanded the forebrain massively, creating our large cerebral cortex. We also saw that primitive mammals did live at the same time as reptiles, including dinosaurs. Early mammals were small, mostly nocturnal and insect-eating. Some of them even laid eggs instead of giving birth to live young, even though they produced milk for their young, like typically we expect as mammalian behavior. They are called monotremes. They stayed hidden in burrows or trees to avoid predators. Dinosaurs occupied most major ecological niche, so mammals remained small and low profile for over 150 million years. So no question for arrival of big mammals like Rhino. Everything changed after the Cretaceous Paleogene extinction event about 66 million years ago, when dinosaurs disappeared and mammals rapidly diversified. This is enough to establish that Rhino didn't come from Dino, but they may have distant association in a broad biological sense because the mammalian ancestor could have lived alongside dinosaurs. Now look at the skull that I have. This is just a replica, obviously. This is T-Rex fossil skeleton replica, and for the most part pretty much similar with the one available in Smithsonian National Museum of Natural History in the Washington DC. So here's the nares or nostrils, a small opening at the front of the maxilla or upper jawbone. In many theropod dinosaur, this is called the promaxillary fenestra. This major, often large opening in the skull situated just in front of the eye socket is called the antorbital fenestra. And situated behind the eye socket, this is the eye socket, behind the eye socket in the rear part of the dinosaur, this is inferior temporal fenestra or infratemporal fenestra. As you can see, some meat-eating dinosaurs, such as this Tyrannosaurus rex, had keyhole-shaped eye sockets, keyhole-shaped, and reconstructions suggest this helped them bite with greater force. In the majority of the vertebrates, is very heavy, including most of the dinosaurs, the eye socket is just a circular hole in the skull, housing the eyeball. However, eye socket shape is very different in large dinosaur carnivores, especially theropods like this. This is for hunter vision, where rhinos got very poor eyesight. They have excellent sense of smell though, and that's because they can browse by using their prehensile lips, while dinosaurs were less reliant on smell in terms of their feeding habits. In the new study, researchers examined these unusual elliptical keyhole or oval eye sockets found in predatory dinosaurs. They postulated that these orbit shapes could have evolved to help the skull absorb the impact as these carnivores attacked or fed on prey. The study also showed that most plant-eating dinosaurs and juvenile individuals even retained a circular eye socket. Only large carnivores like this adopted other morphologies. The research also demonstrated that as the skulls of the theropods got larger, the relative size of the eyeball was reduced. Rhinos, as mammals, have relatively simple, roughly circular or oval-shaped orbit. The eye socket is generally open at the back or partially closed, allowing space for chewing and does not need special structural reinforcement. Compared to their large body size and heavy skulls, rhinos have quite small eyes and eye sockets. If you compare the vision, the primary function of a rhino's head is grazing and supporting heavy horns. Because they rely less on acute eyesight, their eye sockets are small, and the eye itself is smaller than its bony socket, filled with fat and muscles. Now, the eyes are protected by heavy eyelids for rhinoceros and deep set positioning, but not by bony rings. Unlike rhinos, many dinosaurs had a ring of bone inside their eye sockets called a sclerotic ring. This ring acted as a structure to hold the eye, which was specially important for large non-circular eyes like this, preventing them from drooping or becoming damaged. And then also this happened because adaptation for bite force. Research indicates that the unique non-circular shapes of the theropods' eye sockets were an evolutionary adaptation to handle high stresses during powerful bites, preventing the skull from collapsing or losing structural integrity. This skull is designed to support powerful jaws, not for chewing. There is a small brain case relative to the skull size. Rhinos got much larger brains proportionately. Their skull is built to support muscle attachment and horn base. For dinosaurs, the teeth evolved for grabbing, slicing, or crushing. Some dinosaurs replaced teeth continuously. Rhino, no front teeth, incisors reduced or absent. Then there are flat molars at the back for grinding plants. For feeding, they rely mostly on lips, not on teeth. There's an evolutionary reason behind it because dinos are dependent on bite force, right? And rhinoceros required fermentation. So mammals evolved efficient chewing to extract more energy from the plants. But dinosaurs were reptiles, obviously. So most lived between about 230 to 66 million years ago. And all non-avian dinosaurs went extinct, as you just saw, while birds are their only living descendants. Rhinoceros evolved much later, around 50 million years ago, long after the last dinosaurs were wiped out from this earth. So mammals and reptiles, including dinosaurs, diverged from a common ancestor. That means rhinos are more closely related to us, dogs, or even whales than to any dinosaur. Why then some people correlate or connect with them? That's because rhinoceros looks prehistoric and massive, which sometimes give people this impression or that they could be relatives of dinosaurs. Why do the horns look similar sometimes with Triceratops then? This happens because of a concept called convergent evolution, which I mentioned during the hummingbird hawkmoth video. That means different species independently evolve similar features because they solve similar problems, ecological problems. For example, in these two cases, defense against predators, fighting rivals, display for mates. So both animals evolved horns, Triceratops and rhinos, but their horns are built differently. So Triceratops horns, their bone is growing from the skull itself. For rhino horns, it is made mostly of keratin. As you know, I have told this ad nauseum that keratin is the same material as our hair and nails. So some extinct mammals like Perissodactyla, a gigantic hornless rhino relative, were as large as dinosaur. And that's why also people confuse, but still they are mammals. Bottom line, rhinos and dinosaur shared only a very ancient common ancestor. But rhinos are not descendant from dinosaur and are not even closely related. The very ancient common ancestor of rhinos and dinosaur was an early amniote. What does that mean? Amniotes are animals that evolved an amniotic egg, an egg that can survive on land. This group later split into two major branches. Okay, one is called synapsids, which eventually resulted in mammals, including rhinos and humans. Another is sauropsids, which eventually led to reptiles, including dinosaur, birds, lizards, and crocodile. So everything you see here, the teeth, skull shape, jaw mechanics, comes from a reptilian solution. The rhino's head is a mammalian solution. What does it mean? It means same challenge they both have, but completely different engineering solutions nature has provided. Dinosaurs didn't chew like mammals. Their jaws moved mostly up and down. Okay, food was torn and swallowed. Rhinos evolved complex jaw joints. Their lower jaw moves side to side, allowing grinding. I'm sure you have noticed if you have seen my Kaziranga Chronicle any video. The one-horned rhinoceros did not evolve from the fish you see today, but if you travel back more than 500 million years, both share a common ancestor, swimming in the primordial ancient ocean, as you just saw. I usually avoid using AI because of environmental implications, of course, but such topic demands it. The extinct animals that you have seen and are about to see are not randomly generated footage though. I have worked really hard to ensure that every species resemble, if not a complete match with the paleontological data currently available. Otherwise, regular generative AI was throwing up all sorts of ridiculous footage in spite of the trillions of data consumed by LLM every day. But of course, we still know very little about deep timeline, and truth is stranger than fiction. For example, the claim that Earth once endured continuous rainfall for 2 million years may sound dramatic if not false, but the reality is far more complex. Rather than endless global storms, scientists believe the planet experienced an extended period of unusually wet and humid condition. This idea comes from research on the late Triassic period, that is roughly 234 to 232 million years ago, during a climate event called the Carnian pluvial episode. Geological findings reveal a major shift from hot, dry environments to climates with frequent rainfall across large areas of the supercontinent Pangaea. Evidence from rock formations, soil compositions, and plant fossils indicates that moisture-dependent vegetation became widespread. Now, these clues suggest a prolonged phase of increased rainfall lasting about 1 to 2 million years, though not constant rain every single day. Now, researchers believe massive volcanic eruptions released significant amount of carbon dioxide, disrupting the global climate patterns at that point of time. The resulting wetter conditions likely transformed ecosystems, influencing a kind of a forever expansion of new plant species and contributing to the early rise and the diversification of dinosaur species. That's how I changed the sound effects actually, if you noticed. So consider liking and sharing this video, as a lot of effort went into this. So just like we did not evolve from chimpanzees, but we shared a common ancestor about 6 to 7 million years ago, rhinoceros did not evolve from dinosaurs, but they shared a common ancestor, which is an amniot, which is already a tetrapod, an ancient tetrapod basically. Now imagine one-horned rhino roaming in the jungles of Tamil Nadu. Crazy, right?